Hello class. Today we're gonna start to work on chapter 6, and this chapter is talking about mathematics of finance, and we're gonna talk about simple integers, compound integers, continuously compound integers, solving for time, and we're going to talk more about something else. But for now, today I'm going to talk about simple interest and compound interest. So let's go ahead and uh, talk to section 6.1, simple interest. This simple interest is based on the formula A equal to P times 1 per plus RT. So what's A in here? A is amount or the future value, and P is principal or present value. So like the initial amount of money that you have. And then the R in here is stand for annual simple interest rate. Usually not I'm gonna say it's always has to be in decimal form, and T is time in years. Okay, so there is something that you have to remember that in this interest we have to have the keyword is simple interest. Okay, so so let's go to problem down here. So in here I have problem number 1. Say find the total amount due on loan of 1,200 at 8% simple interest, right? So so in here this problem giving you is a problem about simple interest at the end of 6 months. And okay, so based on the formula that that's they given us, we have A, we don't know, right? But P is amount of initial, so that's gonna be 1,200, and R is a rate, a simple interest rate, which is in decimal form. So 8%. 8% in here is gonna be equal to 8% is gonna be equal to 8 divided by 100. Remember that's the percent mean divided by 100, and then that's gonna be equal to 0.08, right? And then for the T is it is the time in years, but in here they're giving us is 6 months. So you have to convert 6 months to be a half of years, like 0.5. So so that means T in here is 0.5, right? Okay. So now I can apply all this information into the formula, and then I have P here is get into here, R here will be in here, and T here will come to this T. All right. So now I'm gonna have A equal to 1200 times 1 plus with 0.08 times 0.5, which is T, right? And so then I have simplify it then in the group in the parenthesis first, and then finally I'm gonna get 1,248. Okay, and in order to interpret this problem, I'm gonna say the total amount due future value on a loan of 1,200 at 8% simple interest at the end of 6 months is $1,248, right? So so that should be the answer. Okay. Now let's go to problem number 2 here, and we're gonna try this. You can pause my video and try it on the own, but I'm gonna start to do it now. Okay. So in here is say find the total amount due on loan of 6,000 at 12% in simple interest, right? So this is simple, right? Simple interest, the columns, and then we have to use this formula at the end of 9 months. So we know that in here the initial amount due on a loan is 6,000, right? So we have P in here is $6,000, right? Actually, yeah, I mean, the initial amount in here is $6,000. And the rate in here is 12%. So I'm going to put out 12% here. But you know, that's the rate has to be converted into the decimal. So it's going to be 12 divided by 100. So that's going to be 0.12, right? For the T time in year, right? In here I have 9 months, which is 0.75 of years. So then T should be 0.75. And now I'm gonna substitute into the formula A equal to P times 1 plus RT, which equal to 6,000 time with 1 plus 0.12, and then time with T was 0.75. Okay, so now you're gonna use a calculator and find this column. So okay, so let me use my calculator here. So let me clean this up, and now I have put 6,000 multiply with parentheses 1 plus 0.12, and I multiply with 0.75, and then close parentheses, and then enter. That should be 6,540. Is correct? Yeah. So then this should be the amount, total amount due on a loan of 6,000 at 12% simple interest at the end of 9 months. So I'm gonna write that the total amount due on a loan of $6,000 at 12% simple interest at the end of 9 months is $6,540, and I will use the red color to circle. Okay, so that should be the answer for samurai. And now let's move down to the next section. So the first section was talk about the simple interest. Now we're going to talk about compound interest, right? So what is compound interest? I'm going to talk about that later, but for now, let's warm up a little bit with a problem that a new atomic cell phone you've always wanted is Mac. at a price of $100. But today only, the phone store is giving 30% discount. The sales tax is 8.25%. Okay, you jump on it and ask the cashier to ring up the sale. The cashier does something strange. He adds in the sales tax on the full price of $100 and then subtract the discount of 30%. You expect him to take the discount off first and then add the sales tax, right? So does matter which way he compute the final price. Okay, so this kind of like the main question is like should we have like discount first and then have the tax, or should we have the tax first and then and then do the discount, right? So usually in the store they're gonna add the tax first and then subtract the discount. But let's see which way is better. I believe that the way the store do is better for them. So that means the price is actually higher than the price that you expect him to take discount and then add the tax. Okay, so go down here to the next page. Okay, so you know that the sales tax rate is 8.25% and the discount is 30% off. Now use method one. It's add sales tax first and then subtract the discount. So it was $100, right? So $100. You actually, I'm gonna just take away the dollar sign. You would add with the sales tax first, which means you add with 8.25%, right? 8.25%. Actually, I can change it to be sorry, right? 8.25% become 0.0825, right? 0.825, right? Because you divide by 100 and you add this number. So you add with the sales tax. So you add 0.0825. Don't forget that you are adding 0.0825 of 100, right? Of $100. So you're adding this one, this percent, this rate multiplied with 100, right? So then you're gonna have 100 plus with 8.25, which is 108.25. Okay. And then here is add the sales tax, right? Actually, yeah. So I'm gonna have like add sales tax, right? And now I'm gonna subtract the discount. So I'm gonna take 108.25. I subtract for 30% of that, right? Subtract for 30% is let me write out 30%. 30% will be equal to 0.3, right? You divide by 100. So then I'm gonna write as 0.3 of this amount. This means you have 0.3 multiplied with 108.25. Okay, so now what is this gonna be? Use a calculator and and find it. So I'm gonna have 108.25 and then minus with 0.3 multiply with 108.25 and then I'm gonna have 75.775. So 75.775 dollar. Okay, so so let's see. Let me circle this so I don't forget it. Right. So let's see if this amount is higher than the second word, which is a word that you want the seller do. Okay, so I need to subtract the discount first, right? So firstly it was 100. You subtract discount, right? Subtract 30%, which is 0.3. So 0.3 times with 100. And then you're going to have 30 and 100 minus 30, you're going to be $70. Okay, now you're going to add in with the sales tax. So in here, say that subtract discount. And then use 70, you're going to add with sales tax. So sales tax was 0.0825 times with 70. And now you will use the calculator and have 70 and subtract, no, not subtract, adding 0.0825 multiply with 70. Oh, okay, 70. Okay, 0.0825 multiply with 70. Okay, and the end, you're gonna have 75.775. Oh, so it looked like we have the same amount, even go by the way from the seller, or the way that he from you thinking. So so let me write down the answer: 75.775. Okay, so let me circle this. All right. So you can see that now the answer of both methods are the same. All right. So let's have another way to look at the problem, right? So now I would like to use multiplication instead of adding stuff. So the first method say adding sales tax first. Okay, which means it's multiplied by 1.0825. Why that's happened? So let's go back with here. You see in the first step here, right? In this one, is actually like if you have 100 plus 0.0825 times 100. You factor 100 out, you have 1.0.0825. And if you adding the things in the parenthesis here, it's going to be equal to 100 times with 1.0825. You see that? That's the reason why instead of adding, you can just multiply with 1.0825. Okay, so let me move down. Okay, so I'm gonna say 100 multiply with 1.0825, right? And that will be equal to um, 100 08.25, right? Or maybe if you don't believe me, you can I mean, you can move down the decimal to 2 place, and then you're gonna have 108.25, right? See that? So, or you can use a calculator to see that, right? So that is like multiply by 1.0825, right? And then subtract the discount by subtract discount, right? Uh, um, so instead of subtracting 30%, I'm just gonna say I multiply by 0.7. So similar by the way I derive, but it should be the same. So now I'm gonna have 108.25. I'm gonna multiply by 0.7. So that will give me, if you use a calculator, so 108.25, you multiply with 0.7, and you will get 75.775. Okay. Similarly, let's do the method number 2. Method number 2, you have do 100 multiply with 0.7D. So multiply with 0.7D, and you have equal to 70, right? So multiply by 0.70. So in this way now, you instead of subtracting for 30% of the 100, I just multiplied by 0.7. So now I'm gonna add the sales tax multiplied by the sales tax actually is mean multiplied by 1.0825. So I have 70. I multiplied by 1.0825. Okay, so let's see if it's gonna be the same answer. So 70, and then I multiply with 1.0825, and I enter. I have the same answer as 75.775. Okay, so again, answer both answer have the same value. So so for now, we don't have to worry when the seller just to do subtract the discount first, or do it later after the tax. Doesn't matter, right? Okay. So let's move down. Okay. So now another example. I want to deposit $100 into an account and earn an account that's earning 5% compounded annually, or it means each year. Okay, so in here the rate is in compounded. It's not in simple anymore. All right. So how much will you have after 10 years? So take a look at a table here from the bank, or I think it is usually is from the bank. You have like a table for each year at the deposit, right? You see the interest at the first year. You have only $5 only, right? See that, right? Because why? Because you take 5% of the 100. So then you have $5 for the interest, and then total you adding 100 with 5 to get 105, right? And then at the second years you're gonna take the zero. I'll take the 5% of 105, right? So actually, maybe I'm gonna do like this. For 100 here, I'm gonna add like 0.05, which is 5%, multiplied with 100. So that will give me the next one, right? The 105 here, right? And then keep doing the same thing. I have adding that 105 with 0.05 times 105, right? And you will later on get to the new amount. After 2 years, you get 110.25. So it's keep going like that until the last amount was 162.89 for 10 years. So what does that mean? That means like after 1 year, you have the new balance, and then this new balance will compound with the rate, and then it's make another new interest for the next years. So you keep going like that, right? Okay. So let's move to the next page. Okay, now the question is, deposit $100 into an account earning 5% compound annually each year. How much will you have after 10 years? Okay, so so you have like A equals to 100 times with 1.05 to power 10 equal to 162.89. Okay, so where is 1.05 here from, right? So let's move up a little bit to see from here, right? So I have 162.89 here. So after 10 years, right? After 10 years, you have this guy, right? So the problem is, where is 1.05 from? Okay, so if I convert back, A here going to be equal to 100, right? Time with 100 plus, no, I'm sorry, I'm gonna have like 100 plus with 100 time with 5%, 5 or 0.0 I'm gonna use 0.05, right? And I want this to be over 10. Okay, so so that could be a little bit tough for us to convert this form. I will say this. It's gonna be 100 times with 1 plus the rate to power t, and actually here's 100 here. I can make it become p. Okay, so that could be the thing that could be the formula for compounded annually. Okay. Okay, so let's see, and then summarize in here, you will have 162.89 after 10 years. Okay, so let's see what's going on after this. Okay, all right, so now we have a formula for compound interest equation. So so this is the formula for the compound interest equation. A equal to P times 1 plus R over M inside parentheses and to power MT. Okay, and A in here is still like a future amount, and then P is principal amount. R is the annual nominal rate. Okay, make sure it's in decimal, right? Decimal number. Okay, and M in here is number of compounding periods per year, right? So it's it could be like say some, for example, it could be I say like annually, right? Annually. Or yearly, same thing. So if we say the compounded annually, that means M in here is only one time compound in a year, right? So so then M equal to 1. If I say like quarterly, then M become 4, right? Yeah, and if it's like monthly, then in a year it's compound 12 times, right? So M equals 12. It could be have like daily also, but at that case, I or the question have to tell you if they define 1 years have like 365 or 360 or 360 days, so then you can get how many times it's compounding in the years. Okay, and then T still is a time in years. Okay, so come back with the formula up here, I guess, right? You can see once again. Okay, you can see that if in here it say that annually, right? Seen it annually, that means if I have P equal to A, no, sorry, A equal to P. Why I put A equal to P times 1 plus R over M times MT, right? From the formula of the compound interest, you have this, right? But in here, since it's annually, annually, right? Annually. Then M in here equal to 1. So then I can substitute into here and get A equal to P equal, times 1 plus R over 1, which is just R. And then M times T, I mean, let me just write 1 here and 1 times T, right? So then when I simplify, I just have P times 1 plus R, everything to power T. So that's the reason why in this case I have guessing. I mean, I have guessed that the formula should be look like that, right? Okay. So so basically, the general formula for compound interest equation is this one, and you have to make sure if the problem I'm talking about compound annually or quarterly or monthly or even daily to change to substitute the m in here. So you're gonna have a simplified formula. All right. So let's move down to the, and do an example in here. Okay. So in this example, I have like 1,200 to invest, and so then this is a principal amount, 1,200, right? And in an annual rate, right? Annual rate, what does that mean? Annual is mean M in here equal to 1, right? One time, make sure it's compound interest, right? Compound. Compound semi-annual. Okay, so actually there is something that I need to change. It's have like semi-annual. Okay, sometimes it's a little confused if we don't read it carefully. It's say compound semi-annual. So so that means one semi-annual is like a half, right? So 1 year we have two time compound. So then m in here has to be equal to 2, right? That's a green graph, right? So what else do I have? I have how much will we have at the end of 10 years? So t in here is 10, right? And also the rate in here equal to 0.06, right? Is here, right? Okay, so I'm gonna substitute everything from here into the formula, and actually I try to figure out what's R over M first. So that is 0.06 over 2 equal to 0.03, and then I found M times T with the power is 20. So so R over M was here, and M times T, use other color, N times T was 20, so it's go to the power here. So then you will have use a calculator, and you will have the answer as 2,167.33 cents. That's going to be the amount after 10 years with the rate of 6% compounded semi-annually. Okay. Okay, so let's do an example for invest 45,000 at an annual rate at 8%. So in here is the principal amount is 45,000. So P is 45,000. Right? Okay. What else do I have? At an annual rate of 8% compounded quarterly. Okay, see that? The word compounded, okay, and quarterly. Quarterly means M had to be equal to 4. I put 4 here, right? And then annual rate of 8%. So that means 8% is a rate. We also have to rewrite as decimal number 0.08. And T is what? So the question is, how much will we have at the end of 5 years? Okay, so that means T equal to 5, right? So now, now I just try to find something such as R over M, which means 0.08 over 4. What is that equal to? Use the calculator. So maybe 0.08 divided by 4 and enter. I have 0.02, right? And then M times T is going to be 4 times 5. And then you're going to have 20, right? Easily. Okay, so use the formula A equal to P times 1 plus R over M power MT. You will have P equal to 45,000 and multiply with 1, okay, plus R over M in here is equal to 0.02, and then close the parentheses and to power M times T is 20. Put 20 here and use a calculator now. So let me clear this. Okay. Clear. Okay, so I have 45,000 multiplied by parentheses 1 plus 0.02 close parentheses and to power 20. So then I will have 6,686. Sorry, 66,867. Okay, so is that reasonable? So take a look at the initial amount. It was 45,000. So after 5 years, you get 66,867.63 cents. So it's look okay because the amount after 5 years is higher than the amount that you invest. That makes sense. So I have 66867.63. Okay. Usually we just gonna round to 2 decimal place because of because of the cent have only two decimal place. So summarize, you're gonna say I will have 66867.63 after 5 years. I mean, you can stop like this and say I will have. And I'm gonna stop this video here. And if you have any question, please see me on the lecture day or the office hour. And I will see you on the next session.